this assignment right here. Let's go ahead and get started with these problems. Here we go. On page 315, numbers 48, 49, and 54. Number 48, find an expression for the area of the triangle. Now, if I ask you to find the area of the triangle, and this had a length of 12, and this had a length of 3, how would you find the area of the rectangle? Well, you would take 3 times 12, wouldn't you? How do you find the area of a rectangle? Length times width. And you would get 36. Same thing, guys. Just because you're not dealing with numbers doesn't change anything. Notice they did not say find the area. They didn't say that. They said find an expression for the area. So area equals what? Length times width. So your length is 4x to the 4th right here, times your width is x to the 4th. Now multiply these together and we're done. Don't forget there's a 1 right here. 4 times 1 is 4. X to the 4th times x to the 4th, you're multiplying like bases. Write the like base once and add your exponents. So there is the expression for the area, 4x to the 8th power. Alright, number 49. Now notice, notice it doesn't say find the area of the circle. If they would have asked you to find the area of the circle and the radius was 10, how would you find the area of a circle? Do you remember? Area equals pi r squared. Remember that? So all you would do is pick up 10 and put it in for your radius right here. You guys know how to do that. Okay, this is old stuff. But the radius is not 10, it's an expression. It's an algebra expression. So that's why they said find an expression for the area of the circle. Well, okay, here we go. Area of a circle is what? Pi r squared. Your radius is 6x to the 4th. So now your area equals pi parentheses. And for r, we're going to put 6x to the 4th because that's what your radius is. Your radius equals 6x to the 4th. We're going to close the parentheses and bring down our 2 right here. And now we're going to simplify. You guys know what to do when an expression is raised to a power. You multiply the exponents. Don't forget there's a 1 right here. Don't forget that, please. So now we have pi, and then we have 6 squared, because 2 times 1 is 2, and x to the 8th. 2 times 4 is 8. Now, we can simplify some more, guys. 6 times 6 is 36. We're going to write that out front. That's pretty normal to do. Then pi, then x to the 8th. 36 pi x to the 8th. So there you go. All that we're reviewing in these past 2 problems were how to multiply like bases, or what to do when a power is raised to a power. Okay, not very difficult. Alright, now we're going to be dealing with an equation, which is right here, and we're going to make a substitution. Alright, here's your equation right here. And let's read the problem carefully. For 1985 through 1994, the total expenditures M in millions of dollars. So this M right here would be your expenditures in millions. Okay, don't forget that. Total expenditures for all the national parks in the U.S. can be modeled by this right here. So if you want to know the total amount of money spent in 1 year on all the national parks in America, here's the model you would use. Now this model's only good from 1985 to 1994, okay? But there's the model. Now t equals 5 represents 1985. Let's write that over here. 1985 is represented by 5, okay? What was the total expenditures in 1985? So we're looking for M. We're trying to find M, okay? And we're trying to find M in what year? 1985. What do we put in for T? It says right here T equals 5 represents represents 1985. So what do I put in for t right here? Well, 5. 5 represents 1985, so 1.066 to the fifth power. Now remember, you do not multiply your bases first. You do not do that. You first take care of your powers. So 1.066 to the sixth, 1.066 to the fifth power, enter, times 575, enter, and you'll get this right here. 791.5. Now that's million, don't forget, because it says right here, M is in millions. So in 1985, $791.5 million was spent on the national parks. Now, what was the total in 1993? So let's do it again. 1993. Well, first of all, if 1985 is 5, then 5 years later, 1990 would be what? 10. So 3 years later, 1993 would be 13. So 13 represents 1993. If 5 represents 1985, then 5 years later, 10 would represent 1990. 3 years later, 13 would represent 1993. So instead of putting a 5 right here for t, I'm going to put 13. So now I have 1.066 to the 13th power, enter, times 575, enter, and I'm getting $1,319.8 million. Alright, if you'll look here, both answers are correct, okay? Alright, moving on to number 61, and that's going to be on page, give me just 1 second here, students. That's going to be on page 365. Now, you should be totally confused on this problem. You need to turn back to page 362. Everybody hear me? Turn back to page 362, please. Look at the top of the page. They give you formulas. Are you whistling? For example, in this problem, we're dealing with the length of an edge of a icosahedron. Okay? So if you'll look at the top of page 362, you'll see a formula that says this. Volume equals 2.18169 a cubed. Now, in all of these formulas, a stands for the edge, the length of the edge, okay? So it says find the length of an edge that has a volume of 21. So they're giving you the volume, you're looking for A. Very simple. They're giving you the volume, you're looking for A, because A stands for the length of an edge. And that's what you're looking for. Find the length of an edge. So here we go. For V, I'm going to substitute 21. Now I'm going to solve for A, so I want to get A cubed by itself. I'm going to divide both sides by 2.18169. If I divide both sides by 2.18169, I'm left with A cubed over here. Over here I'm left with 9.626. Alright, now, if I have an A cubed and I want to just get it down to an A, I take the cubed root. But if I take the cube root of one side, I must take the cube root of the other side. Do not put plus minus. You never put plus minus when the index is odd. Never. Okay? So, here we go. The cubed root of this would be 2.127 or 2.13. Now we were dealing with what? Centimeters. So 2.13 centimeters is the length of one of the edges. Okay, now that you know what these formulas are, you should be able to do number 62 quite easily. Now we're dealing with the edge of a dodecahedron, alright? And so the formula is V equals 7.66 312, 312, a cubed. And once again, they've given us the volume, and they want us to find the edge. A, so it's done the exact same way. Okay, so 30 goes in for V, and now I'm going to solve for A. So now I must divide both sides by 7.66312. Alright, divide both sides by that. So, put that here, and put this over here. So we're going to divide both sides by this number here. Those cancel out, and I'm left with a cubed over here. On the left side, I would have 3.91, 3.915. Okay, now let's take the square root or the cube root of both sides. If we have an a cubed, we'll take the cube root of it. If we take the cube root of one side, take the cube root of the other side. The cube root of a cubed is a, and the cube root of 3.915 is 1.58. Now the volume was in cubic feet, so it'd be 1.58 feet. That would be your answer. 1.58 feet. Now number 63 is a little trickier. Just bear with me and listen carefully, okay? First of all, you're not going to find the formula for the volume of this problem on page 362. It's not going to be there because you're dealing with a sphere. You're dealing with a ball or a sphere, okay? So do we have a formula for the volume of a sphere? Well, sure we do. On a test or a quiz, I would give it to you, okay? So don't worry about that. I would actually give it to you so you would know what it was, alright? Now I'm going from memory. I believe it's 4/3 pi r cubed. Alright. Let me see if I can locate that somewhere. Here it is. Yes, that's correct. 4/3 pi r cubed. So that's the volume of a sphere. Okay. Now, it says the target ball in lawn bowling is called the jack. It weighs this many grams. It has this much of a density. What is the radius? Now guys, here's the problem. In this problem back here, they gave us the volume. In this problem back here, they gave us the volume. In this problem here that we're on, they don't give us the volume. Now this is something you might not have known, okay? But there is another formula for finding any volume of a three-dimensional figure, and that is you can take the mass and divide it by the density. I'm sure you didn't know that. And again, on a test or a quiz, I would probably just give you the volume. If I didn't, I would give you this formula here so you would know what to do. So we really need to know the volume before we can find the what? The radius. And that's what they're asking us to do. What is the radius? Well, we don't know the volume, so we gotta find the volume, alright? Well, here's how we do it. Mass over density. So it tells us, it weighs about 283 grams, which would be the mass, okay? That weight would be the mass. So the mass is 283. The density is 2.11. So with a calculator, let's divide these. And we'll get 134.12322. That's your volume. 134.123. And all of that equals 4/3 pi r cubed. Now you're solving for pi, okay? So I'm going to divide both sides first of all by 4/3. Okay, let's take it real slow. Divide both sides by 4/3. These will cancel, leaving you with pi r squared. All right. So I have 134.1232 divided by 4/3, and you're going to get 100.5924 if you round correctly. Now divide both sides by pi. There should be a pi button on your calculator. So divided by pi, and that's going to give you 32.01956 equals r squared. Now, students, you know how to get rid of a r squared. Take the square root of both sides. If you take the square root of one side, take the square root of the other side. By the way, do not put plus minus because you're dealing with the length of the radius, and a length can never be negative. So you're dealing with the length of a radius. So do not put plus minus. Now, when you take the square root of r squared, you're left with r, and the square root of this number here is 5.66. 5.66. What we're dealing with? Cubic centimeters. So it'll be centimeters. 5.66 centimeters. Alright. And I'm not sure. Hold on, let me look this over real quick. Okay, guys, I'm back, and I apologize. You know your math makes little mistakes. This is r cubed, isn't it? So that should be a 3 right there. I brought that down incorrectly. That should be a 3. So we take the cube root of both sides. Sorry about that, guys. So the cubed root of this number would be 3.175 or 3.18, which is the correct answer. So everything is fine here. Please don't freak out and get all worried. I just simply, when I brought down this 3, I changed it for who knows what reason to a 2. Okay? And it should have been a 3. So if you have a 3 right here, to take the cube root of both sides. So guys, you see what we're doing here? I'm just teaching you how to take equations like these and solve these, okay? We know how to do this. Alright, okay, let's continue on. Number 65. For 1980 through 1990, the admission receipts for spectator sports in the United States was this right here. Can be modeled by this. Now, as is billions of dollars that was made for admission to sporting events. And T is the time in years. Now 0 equals, notice that 1985 is represented by what number? Do you see it right here? T equals 0 represents 1985. So there we go. Now, here's my model. S equals 2.84 plus 0.014 t cubed. Now watch. In what year? So we're looking for time, are we not? In what year were the receipts approximately 3.2 billion? Now, S is already in billions, so I'm just going to put 3.2. And now I'm solving for t. And guys, we know how to do this so well. Get t cubed all by itself, so bring this over and make it negative. So 3.2 minus 2.84 gives you 0.36. So 0.36 equals 0.014 t cubed. Alright, now, next, in order to get t cubed by itself, we're going to divide both sides by 0.014. Alright, and did not want to do that, and we'll try that again, and here we go. So we're going to divide both sides by 0.014. These cancel, leaving you with t cubed, and 0.36 divided by 0.014 gives you 25.71429, rounded correctly. Now, we have 2 to the cube. We're solving for t, so we're going to take the cube root of both sides. Okay, take the cube root of both sides. The cube root of t cubed is t, and the cube root of this number here would be 2.95. 2.95. No, hold it. That's not your answer. Look at your answer. It's not your answer. The question is, in what year were the receipts approximately 3.2 billion? Now, we're at 2.95. I'm going to round that to 3. So t equals 3. Now, come on, guys, think about it. If 0 represents 19 1985. 3 years later would represent what year? 1988, and that's why the answer is 1988. Okay? It's not asking for how much time, it's saying in what year would the receipts be this much. Okay? And that is the answer. Alright, moving on. Now, these next two are pretty challenging, but I want you to really think deeply, and I think you'll be okay. Alright? In what the areas of the circles below are 15 square centimeters and 20 square centimeters, okay? Find the ratio of the radius of the small circle to the larger circle. Now, if I asked you, listen to me carefully, if I said what's the ratio of the guys to girls in your class, that simply means you would put the guys up top and the girls on the bottom. And I'm not sure, we probably got about what? I don't know, 3 or 4 young ladies. I guess maybe 4 or 5 guys, I don't know. Maybe I said that backwards. It doesn't matter. Anyways, the ratio, I'm just making this up, the ratio will be 5 to 4. The ratio of guys to girls, 5 to 4. Guys goes up top, girls at the bottom. So if it says the ratio of the radius of the smaller circle to the radius of the larger circle, that means you want the radius of what? I'm going to put SC, smaller circle, over the radius of the what? Larger circle. That's what it says. Find the ratio of the radius of the smaller circle to the radius of the larger circle. So my final goal is to get the radius of my smaller circle on top of the radius of my larger circle. That would be my ratio right there. Does that make sense? Just like boys to girls. Radius, smaller circle to radius of larger circle. So it looks like to me, guys, we've got to find the radius of each circle. So let's start with the smaller circle first. They're giving us the area, right? The area of the circle. The smaller circle is 15. I know it's smaller because this area is smaller than this area. So that's the smaller circle. So the area of my area is pi r squared. The area of my smaller circle is 15. So 15 equals pi r squared. So what is my radius? Well, divide both sides by what? Pi. So now I have 15 pi. 15 over pi equals what? R squared. Got it? Now take the square root of both sides. And just leave it like this. Don't try to type it into your calculator. Just leave it like this. There you go. You found the radius. Was that easy? You put 15 in for your area. And you found the radius. So that goes up top right here. Square root of 15 over pi. Everybody got it? Now let's find, this is a 15 right here. Now let's find the radius of the larger circle. We can do this. Here we go. Let's find the radius of the larger circle. Alright, here we go. What is the area of the larger circle? 20. So we'll put a 20 right here and go to pi r squared. Now divide both sides by pi because we're studying or we're trying to find the radius. So I'm left with r squared and then over here 20 over pi. Don't type that in, just leave it like it is. Now take the square root of both sides. The square root of r squared is r. The square root of this would be this. So now that goes in the bottom of my fraction over here. So guys, we did it. Now we're not quite done, but look what we did. We got the radius of the smaller circle over the radius of the larger circle. All that we have to do now is simplify. That's it. We can do that, guys. It's not difficult at all. Okay? We can definitely do this. So here we go. Let's simplify this. First of all, I taught you this principle a long time ago. If you have the square root of 5 over the square root of 7, that's the exact same thing as the square root of 5/7. The radical can go around the whole fraction. Well, same thing here, guys. I have the square root of this over the square root of this, so that really is the square root of 15 over 11 over 20 over 11, okay? Now, come on guys, we're big algebra 2 students. We can take this and simplify it and keep it under the radical. We have 15 over 11 right here. So 15/11 divided by what? 20 over 11. Well, you guys know when you're dividing fractions, make this multiplication and flip your fraction. Put the 11 up here and put the 20 down here. So now we have 15 over 11 times 11 over 20. Your 11's cancel, leaving you with 15 over 20, which of course reduces because 3 goes into both of them, or 5 goes into both of them 3/4 time. So look at that, this entire thing. Did I call that 11? Sorry guys, boy oh boy, I'll tell you, I get sloppy, don't I? I don't know how you all put up with me. Pi, sorry guys, but either way your pi would cancel, whether it's 11 or whether it's pi or whether it's a million and a million, they still cancel out. So you're left with 3/4. So all of this became 3/4. So now we have the square root of what? 3/4, which is the same thing as what? The square root of 3 over the square root of what? 4. Do we know the square root of 3? No, but we know the square root of 4 is 2. So there we go. You cannot reduce that any further. Your answer is square root of 3 over 2. Square root of 3 over 2. And if you want to see it, here it is. Square root of 3 over 2. Go back and watch again if you need to. That would make a good test or quiz problem. Ratios like this, that would be good, okay? Alright, another one just like the last one. What is the ratio right here? What is the ratio of the radius of the sphere to the radius of the cylinder? So my ratio is radius of sphere over, I'm going to use ditto marks, radius of cylinder. So I've got to find the radius of the sphere first. Here's my formula. Volume equals 4/3 pi r cubed. They tell me the volume for both of these is 4. So for this sphere, the volume equals 4. For this cylinder, the volume equals 4. So for volume, I'm going to put 4. 4 equals 4/3 pi r squared, okay, or pi r cubed. Now, let's divide both sides by 4/3, first of all, to get things started, to get r by itself. So these will cancel, leaving me with, let's see, 4 over 1 times 3 over 4 would be 3. So now I have 3 equals pi r cubed. 4 divided by 4/3 is 3. Now divide both sides by pi. And I would not type that in, just leave it 3 over pi. So now I have 3 over pi equals r cubed. These cancel. Do you see what I've done? Now take the cubed root of both sides. And here we go. The cube root of r cubed is r, and we'll leave this just like it is. So just bring that down. There we go. There's my radius. I found it. Perfect. So that's going to go all the way over here on top of my fraction. Okay, so here's my fraction bar right over here. And this will go up top right here. That's the radius of the sphere. Now let's find the radius of the cylinder. Now, here's the formula I'm going to use. V equals pi r squared h. The volume is 4. Pi is going to stay pi. My radius is, look, r. My radius is r. So I've just got r squared. My height is 3r. So I've got a 3r here. Okay. Now, look guys, I could do some simplifying real quick. I've got pi times r squared 3r. Well, r squared times r, now I have pi, then a 3, and then an r cubed, right? Because I have r squared times r to the 1. When you're multiplying like bases, write the base ones and add the exponents. So we're looking at the exact same thing here. Now let's get r by itself. We're going to divide by what? 3 pi. Divide both sides by 3 pi. These will cancel, leaving you with r cubed. 4 over 3 pi is simply 4 over 3 pi. Now take the cube root of both sides. The cube root of r cubed is r, and the cube root of this would just be the cube root of what? 4 4 over 3 pi. There we go. Pretty simple. Okay. And so now we have this radius right here, and that'll go in the bottom. That's the radius of my circumference, of my cylinder, excuse me. So let's move this over here in the bottom. So now it looks like to me all that I have to do is just simply simplify this complex fraction I have here and I'll be done. Let's get some room here and let's get to work, okay? Now first of all, like the last problem, you understand if I have a cubed root over a cubed root, I can rewrite that with one big cubed root. That'd be 3 over 11, no, not 3 over pi, sorry. 3 over pi over 4 over 3 pi. Now, we have this fraction here being divided by this fraction here. So here we go, we can simplify that. 3 over pi divided by 4 over 3 pi, right? So let's multiply, let's flip these fractions. The second fraction, 3 pi, is up here. 4 is down here. Look at your pi. Your pi will cancel with your pi, leaving you with 3 times 3 is 9. 1 times 4 is 4, and 9 fourths. So this whole expression under the radical became this. Alright? So now I can simply write the cube root of 9 fourths. Now there's really not a whole lot more I can do with this. I think this is the answer. I think it's the answer. Yes, it is. There's the answer right there. There's nothing more I can do. Now, Mr. Erhard, how'd you know that? Well, split it up. Cube root of 9 over the cube root of 4. We don't know the cube root of 9. We don't know the cube root of 4. So really not a lot more you can do. So this would be our final answer. There's the ratio of those two radii. Okay? Alright, moving on. Now this is a really, really tough problem. I'm going to try to solve this cold turkey. I want to tell you right now, you will not be given one of these in your test or quiz. You do not have to take notes on it. You can sit and watch and not write anything if you don't want to. Or you can take notes. It's up to you. So why are we doing this? It's a waste of time. No, it's not. It's good for you to see problems like this. This would be the stuff these would be the type of problems here that we would do in pre-calculus next year for those who take that class, okay? Tough problems like this. So I'm going to work it out quickly. I'm not expecting you to understand. I'm not going to quiz you or test you on it. But it's still good for you guys every now and then to see problems like this that stretch your brain and stretch your thinking skills. So I encourage you to take notes. But I'm not going to make you. You can just sit and watch if you want to. In a right triangle, a line segment is drawn from the right angle perpendicular hypotenuse. I've got to draw a line that comes across from the right angle to this side so that it's perpendicular there. Let h represent the length of that segment, so this will be h right here, and let x and y represent the two lengths of the hypotenuse. So I'm going to color this black from here to here, and we're going to call that x. Alright, I'm going to color this blue from here to here. That's blue, and we're going to call that segment y, okay? Now, one of these lengths is the geometric mean of the other two lengths. Which is it? Well, this is going to be really tough. I'm probably going to shoot way over your head on this, but here we go. My whole premise is this. A geometric mean equals what? The square root of how many numbers? 2 numbers, right? You remember that? We've learned that. The geometric mean is the square root of 2 numbers being multiplied. Don't forget that, okay? We're going to come back to that at the end. Alright, now, we're going to come over here. I'm going to put an A and a B. A for this side, B for this side. Now, first of all, let's look at the big triangle, okay? I'm going to write an expression for the big triangle right here. Okay? This is a leg. This is a leg. If you add these two together, x plus y, that's your hypotenuse. Got it? So, looking at the big triangle, I can say that a squared plus b squared equals x plus y squared. No, I don't expect you to understand that. It's Pythagorean's theorem. leg squared plus leg squared equals hypotenuse squared. Okay, now let's take a gander, a look here at the smaller triangle right here. See the small triangle right here? That's a right triangle. It is, Mr. Harris. Well, yeah, if that's a right angle right here, that's a right angle right there. So here's my hypotenuse. So I could also say this. Look at this triangle here. I have leg, leg, and here's your hypotenuse over here. I could say x squared plus a squared equals a squared. So I'm going to write that, okay? I'm going to write leg squared, which is x is one of my legs, h is one of my legs, equals a squared. Alright? Now, let's take a look at the smaller triangle here. This is also a right triangle, isn't it? Sure, there's a right angle right there. So this is my leg, H. This is my leg, Y. And this is my hypotenuse across from the right angle. This is my hypotenuse, B. So I could say B squared plus Y squared equals, or H squared plus Y squared equals B squared. Alright, so let's go ahead and write that down. And now we have what I say, Y squared plus H squared equals B squared. Now, students, I want to pause and again say to you, hey, you're not responsible for this. Just sit back and watch and at least say to yourself, does this make sense? I hope it makes sense so far. We use Pythagorean's theorem on the big triangle right here. Then we use Pythagorean's theorem on the small right triangle. Then we use Pythagorean's theorem on the small right triangle here. That's not that hard. Now, look at this. What can I put here for a squared? Well, a squared equals what? This right here. So for a squared, I'm going to put x squared plus h squared plus, what can I put for b squared? Well, b squared equals this. Y squared plus h squared. That's not too hard to see, is it? I made a substitution for this right here and a substitution for this right here. Okay, now x plus y squared just means what? X plus y times what? X plus y, you know that. X times x is x squared. X times y is xy. Y times x is xy. And y times y is y squared. There's 1xy, 1xy, that would be 2xy. X squared plus 2xy plus y squared. So if I take x plus y, quantity squared, I can put this in place of it right here. Alright? This right here. And maybe I can rotate it just a little. There we go. Okay. So really not too bad here. Okay. Now, let's see what else we have here. On the left side over here, we have h squared, h squared. They're like terms, aren't they? So really I could put x squared plus y squared plus 2h squared equals all of this. H squared plus h squared, 2h squared. Now, look at this. See this x squared? Bring it over to the other side and make it negative. It cancels with this. See this y squared? Bring it over to the left side, make it a negative y squared, and it cancels with this. So now you're left with 2h squared equals 2xy, correct? Now, divide both sides by 2. And you're left with what? H squared equals xy. Now take the square root of both sides. The square root of h squared is h, and the square root of xy is xy. Booyah, we're done. Guys, this goes back to you track 1 geometry students last year. Remember, there was a theorem that we learned that said if a line is drawn, if an altitude is drawn from the vertex of the right angle to the hypotenuse, listen, we learned this last year. You should remember this. If a line is drawn, if an altitude is drawn from the right angle of a right triangle to the hypotenuse, it divides the length of that line is the geometric mean of the two segments right here. I just proved it to you. Here it is. H equals these two numbers multiplied together, the square root. So, one of these lengths is the geometric mean of the other two lengths, h. H is the geometric mean of the lengths x and y. Okay, now, you might have been lost from the moment I said the words in a right triangle, okay? Alright, you might have totally gotten this, but it's good for all of you to see a problem like this, even though I won't give you one on a test or quiz. Alright, numbers 39, 40, and that's it. So we're basically done. Hang in there, guys, okay? This is it. Write a function that gives the radius r of a circle in terms of the circle's area a. We're not going to sketch the graph. I already told you that. We're not going to sketch the graph. So, here we go. How do you write a function radius in terms of a? Well, let me show you. First of all, write the formula for the area of a circle. Got it. Now you know what this is right now. This is area in terms of radius, or a in terms of r. How do I know that? Listen to me carefully, because what is all by itself? A is. So if a is all by itself, we say a is a function of r, or you can say a is written in terms of r. They want us to do the opposite. They want us to write r in terms of a. Well, guys, all that means is get r by itself. Divide both sides by pi, and I'm left with a over pi equals r squared. These canceled. Now take the square root of both sides. The square root of r squared is r. The square root of this is this. You're done. Listen to me. It's not r all by itself. Sure it is. So we have r in terms of a, or r as a function of a, and that is the answer. There it is. R equals the square root of a over pi. Look, guys, this would make a great test or a quiz question right here. So make sure you understand this. When I ask you to write a function that gives something in terms of something, this first something, if you will, that's what you want to get all by itself. So when it says r in terms of a, that means simply get r by itself with a over here. Let's try another one. Here they want us to write a function that gives r in terms of v. R in terms of v, that means you want to get r by itself with v on the other side. So we better start off with the volume of a sphere. Remember what it is. 4/3 pi r cubed. Now right now, we do not have r in terms of v. We have v in terms of r. Don't we? Because what's all by itself? V, and what's over here? R. Got it? We don't want v in terms of r. We want r in terms of v. So let's get r all by itself, alright? Now, because we have a multivariable equation here, in other words, we have different variables, I really don't like that. Well, I was going to say multiply everything by 3 to get rid of your fraction, but I'll tell you what, we've not done that the whole video, so let's not start that now, okay? Let's just go ahead and get r by itself like we've been doing. So here we go. If we're going to get r by itself, the first thing we do is divide both sides by 4/3. Divide both sides by 4/3, okay? So these cancel, and you're left with pi r cubed. Now, v divided by 4/3, right? V divided by 4/3. So here we go. V divided by 4/3. We're going to simplify this. That means what? Times, and flip the second fraction, 3/4. So we have v times 3/4. V is over what? 1. So v times 3 is 3v, and 1 times 4 is 4. So we have 3v over 4, which is the same thing as 3/4 v. Alright? 3/4 v. Exact same thing, okay? Exact same thing. Now, let's divide both sides by pi to get r by itself. Pi. Alright? So now we've got some more simplifying to do. Now I have divided by pi. So this divided by this. Alright. Now, 3/4 v is the same thing as 3v over 4 divided by, what are we dividing by? Pi, or pi over what? 1. This divided by this. So, flip this and multiply 1 over pi, and 3v times 1 is 3v. 4 times pi is 4 pi. So now I have 3v over 4 pi. Now let's take the cubed root of both sides to get r by itself. And I think we're done. We're left with the cubed root of 3v over 4 pi equals, well, when you take the cube root of r cubed, you're left with r. So look what I have now, students. I have r all by itself, so and v over here. So I have r in terms of v, r in terms of v. And look at the answer right here. Right, there it is. The cube root of 3v over 4 pi. Hey guys, look. These are good, solid word problems that should challenge you and make you think. Okay? I hope this video has been help to you. If you have any questions, don't hesitate to call or email.